Ultimate Solution. In this video, we are going to talk about how we apply the knowledge of what we know about finding the inverse of a matrix. In this way, just applying the matrix operations, multiplication, addition, and subtraction. So we shall attempt these 5 questions. Right. So starting off with number 1, we are told that if B is equal to 2, 4, 1, 3, and AB is equal to I being the identity matrix, we're asked to find A. But now, what do we know? What can we use that we know, yeah? So for number 1, we know that for a matrix B, right, the product of the matrix B and its inverse will give us the identity matrix. So now if AB is equal to I, this implies that A is definitely the inverse of B, right? Since the product is giving us an identity matrix, the identity matrix I being equal to 1, 0, 0, 1, right? So now we're simply finding the inverse of B. So A, which is the inverse of B, shall be 1 over the determinant. The determinant shall be 2 times 3, which is 6, minus 1 times 4, which is a 4, then multiplied by 3, 2, minus 4, minus 1. Like this, such that the determinant, the inverse is 1 over 2, 3 minus 1, 4, 2. So this is A, right? This is the A that we're required to find. A being the inverse of B, right? Then number 2, find Y if Y times, so this is a multiplication. So Y times minus 2, 0, 3, 1 is equal to the identity matrix, right? This definitely denotes that Y is what? Y is the inverse of this matrix, because we know that the inverse, this matrix, the product of this matrix and its inverse will give us this identity matrix. So Y, this is for number 2, Y shall be the inverse of this matrix, which is 1 over the determinant. So minus 2 times 1, we get a minus 2, plus minus 3 times 0, that's a 0. So we get a minus 2 here, which is just minus half. And multiply by 1 minus 2, 0 minus 3. So this is the Y that we need. And please take note that this is a negative, minus half. Then number 3 says that find B if A is equal to 2 minus 2 minus 1, 3. And AB is equal to 4 minus 2, 0, 7. Right. So now we are told that AB, this is now for number 3. Let me use red here. For number 3, we are told that AB is equal to 4 minus 2, 0, 7. But we know the matrix A, which is this. So now what can we do? How can we apply this? Right. We're simply saying that here if we divide by A, right, or maybe let's call this matrix C. So let's say let 4 minus 2, 0, 7 be equal to C, such that we've got AB is equal to C. So dividing both sides by the matrix A that we know, right, A and A cancel A, B. So dividing by a matrix is just the same as multiplying by its inverse. Like this. So to get B, we are simply saying the inverse of A times C. So first step, we have to find the inverse of A. Right? Inverse of A shall be 1 over the determinant, which is 2 times 3, we get a 6, minus 1 times minus 2, that's a 2. And then this will be 3, 2, and then 2, 1. So this is the inverse of A. So inverse of A is equal to 1 over 4 3, 2, 1, 2. This. So to get B, we're simply saying the inverse of A multiplied by C. Right? And then we know that our C is here. So allow me to erase this. Right, allow me to erase this. Okay, so we are saying that inverse of A, 1 over 4, 3, 2, 1, 2, times C, which is 4 minus 2, 0, 7. Right, and now what do we get? Right. So here we're saying 3 times 4, we get a 12. 12 plus 2 times 0, that's a 0. So we get 12 here. And then 3 times minus 2, we get a minus 6. And then minus 6 plus 2 times 7, that's minus 6 plus 14. Then we get an 8. Then 1 times 4, we get a 4 plus 2 times 0, that's a 4. Then here, for the last element, we're saying 1 times minus 2, right? 1 times minus 2, we get a minus 2, plus 2 times 7, that's 14. So minus 2 plus 14, we get a 12. Then simplifying with this 4, multiplying each element of the matrix by 1 over 4, we get a 3, 2, 1, 3. So therefore, we are saying that B is equal to 3, 2, 1, 3. Right, this is the answer that we get. Then I'm moving on to number 4. So allow me to use this part. Number 4. Okay, moving on to number 4. We've got matrix A, matrix B. First part requires us to find AB. So AB, this is for number 4. We shall find AB 2 minus 3, 0, 1 times 1 minus 1 minus 1, 3. So first element, 2 times 1, we get a 2, plus minus 3 times minus 1, we get a 3. So 2 plus 3, we get a 5. Then second element, we're saying minus 2 times minus 1. Sorry, 2 times minus 1, we get a minus 2, plus minus 3 times 3, we get a minus 9. Minus 2 minus 9, we get a minus 11. And then third element, 0 times 1, that's a 0. Plus 1 times minus 1, that's minus 1. Then the last element, we're saying 0 times minus 1, that's a 0. Plus 1 times 3, that gives us a 3. So this is AB, which is the first part. Second part requires us to find the inverse of A, which you're going to say 1 over the determinant. The determinant being 2 times 1, which is 2. Right? Minus 0 times minus 3, that's 0. In times the matrix 1, 2, 3, 0, like this. Then the inverse of B, inverse of B as well. This is now the third part, part C. Inverse of B, we're saying 1 over the determinant. So the determinant is 1 times 3, which is 3. Then minus 1 times minus 1, that's a 1. So 3 minus 1 times the matrix 3, 1, 1, 1, which would be equal to 1 over 2, 3, 1, 1, 1. Like this. And now the last part says, show that the inverse of AB, right, which is the inverse of this AB here, is equal to the inverse of B multiplied by the inverse of A. Right, so we're saying the inverse of AB, we can calculate it separately. So we can say the inverse of AB is equal to 1 over its determinant. Determinant shall be 1, 5 times 3, that's 15, minus 1 times minus 11, that's 11. 15 minus 11, we get a 4. And then we've got 3, 5, 11, 1. So this is the inverse of AB. Now we are now saying, what's the product of the inverse of B and the inverse of A? Right. So I'm simply multiplying these two now, such that we're saying inverse of b multiplied by the inverse of a. This is 1 over 2, 3, 1, 1, 1, multiplied by 1 over 2, inverse of a, 1, 3, 0, 2. Right, and of course, the halves can multiply out to give us a 1 over 4, and then we have a 3, 1, 1, 1, multiplied by 1, 3, 0, 2. So we're simply finding this, right? So 3 times 1, that's a 3, plus 1 times 0, that's a 3. The second element, 3 times 3, that's 9, plus 1 times 2, 9 plus 2, that's 11. The third element, 1 times 1, that's 1, plus 1 times 0, that's a 1. Then the fourth element, 1 times 3, that's a 3, plus 1 times 2, that's 3 plus 2 to give us a 5. So as you can see, right, that this is the same result as this. So we've proven that this is true, right? And then now this is for number 5, I think. This is for number 5, which is the last question. So allow me to erase this part. Okay, so number 5 says that if matrix 1 minus 2x4 is no inverse, what is the value of x? So we say that if a matrix is not inverse, this is implying that the determinant is equal to 0, right? So in this case, the determinant being equal to 0, we're simply saying 1 times 4 minus x times minus 2 should be equal to 0, such that 4 plus 2x is equal to 0, and then solving for x, x is equal to minus 2. Simple and straight to the point. So this is how we find the value of x, x being equal to minus 2. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.